Hello, this is a video on current electricity. So this is the second part of the video series, and here we'll be looking at symbols for components. So when you have electric circuits, what are the kind of symbols you will be coming across? So the first one we look at is an ammeter. So ammeter, this is something that looks like that. And we have this circle and we have an A written there. This is an ammeter. We have a circle with a V written inside is a voltmeter. And you know, an ammeter measures current in amps, and voltmeter measures potential difference, also known as voltage, in volts. An ammeter is usually connected in series in an electric circuit. What do I mean by series? You connect it along the wire, along the resistor, along the wire in which the conductor or the resistor is connected. So for example, if you want to measure the current through a resistor, you have to connect an ammeter in series with the resistor, something like that. So you can see the single wire connects them. Okay, so that the current that flows through this resistor is what flows through the ammeter. An ammeter usually have very low resistance, such that all the current, most of the current that flows through this resistor will flow through it. On the other hand, for voltmeter is connected in parallel in an electric circuit. So if you have an electric circuit, let's say you have a resistor and you want to measure the potential difference across this resistor, you connect the voltmeter like that in parallel. So by parallel, I mean that there will be a kind of node. That's the best way to identify parallel connection. Yeah, we'll look at this later on, parallel and series circuits, but just a kind of brief introduction to it. So we have a node, that is a point where you have a T-junction, like three or more wires being connected together. So this is a junction or a node. This is another junction and a node. Anytime you can identify that, you have a parallel connection there. So voltmeter is usually connected in parallel to the resistor. So this voltmeter can measure the potential difference between these two ends of the resistor. And voltmeter usually have very high resistance. And the reason why that is the case is that the current that will flow through it will be very, very low. What we want is that most of the current will flow through the main part of the circuit, you know. Yeah, you have an ammeter connected here. So if you have, let's say you have a voltage source here, if the current flows like that, what we want is that most of the current to go through and come and go around the circuit. So let me complete the circuit. So that's what we want. We want the current to go like that. So we don't want the current to branch here and flow through the voltmeter. So that's why this voltmeter will usually have very high resistance in principle. Okay. That was like a quick digression there. Then you also have another symbol, which is I've shown you before, cell. Cell, you have two lines, one big line and another small line, like that. When you see that symbol, it means it's cell. So when you have more cells connected in series, like that, this is battery. Okay. Then you also have resistor. Seen that before, previous video. But resistor can be like this, or it can be like this. So these are resistors. Then this is the standard resistors. You can have variable resistor. You have an arrow like that. So variable resistor means the resistor can be adjusted. The resistance of the resistor can be adjusted. Or you see like this, with variable resistor. Then you can also have this. You have this. You have a circle with an arrow inside it. It could be pointing down or whatever, in any direction. Doesn't matter. It's called a galvanometer. It's used to detect very small amount of current. So we'll learn more about that later on. Okay. Then you can also have something that looks like this. This is this switch. Like this is closed here. This is closed. If it is open, you say it like that. So this is open. So when the switch is open, then that means there is no current flow. The circuit is an open circuit. Okay. So that's it for the video. And I'll see you in the next video.